Hi everyone, welcome to Math Minds. Our learning target for this video is I can sketch the graph of a rational function by attending to precision. Now let's take a look at the problem of the day. Identify the key features of rational functions, then use those features to graph the function on the accompanying coordinate grid. F of x equals x squared plus 2x minus 8 over x squared minus x minus 2. So we want to start off by rewriting this function in factored form. For our numerator, we have x minus 2 times x plus 4 over x minus 2 times x plus 1. Now that we have done this, we can move in to finding the y-intercept. To find the y-intercept, we are going to find f of 0. In other words, our x is going to be equal to 0, and we're going to substitute 0 into our function. So we have 0 minus 2 times 0 plus 4 over 0 minus 2 times 0 plus 1. And we're going to simplify this, and this is equal to 4. So our y-intercept is at the coordinate 0, 4. Now let's find our x-intercept. To find our x-intercept, we are going to be setting our numerator x minus 2 times x plus 4 equal to 0. We are going to solve for our x values in our numerator, and this is going to be x equal to, x is equal to negative 4. We have two x-intercepts at 2, 0, as well as negative 4, 0. Now let's find our wholes. Our whole is when the function has a factor in common in the numerator and denominator. So here we have x minus 2, which I am circling in red. To determine the location of the whole, we are going to set x minus 2 equal to 0, and we are going to solve for x. Doing so, we find x is equal to 2, and we can now find our y-coordinate for the whole. To do this, we will be substituting our 2 into our remaining function. So we have f of 2 is equal to 2 plus 4 over 2 plus 1. And this is going to be 6 over 3, which is equal to 2 for our y-coordinate. So our location for the whole is going to be 2, 2. We can now move in to finding our vertical asymptote. We are going to be using the remaining factor in the denominator. This is x plus 1, and we are going to be setting this equal to 0 to solve for x. X is equal to negative 1, and this is our vertical asymptote. Now let's find our horizontal asymptote. For this, we want to look at our exponents in our original function. We have a 2 in the numerator and a 2 in the denominator. Because the exponents in the numerator and denominator are equivalent, our horizontal asymptote of y is going to be equal to the ratio of the coefficients. So we have an imaginary 1 in front of x squared here, as well as an imaginary 1 over x squared in the denominator. So our horizontal asymptote is going to be 1 over 1, which is equal to 1. Now let's find an additional point to work with just for the sake of this graph. We're going to choose negative 2 as our x. We're going to be substituting negative 2 into our function. So f of negative 2 is equal to negative 2 minus 2 in parentheses times negative 2 plus 4 in parentheses over negative 2 minus 2 times negative 2 plus 1. And this is going to be equal to negative 2. So our additional point will be negative 2, negative 2. And now let's begin to graph. Now let's start off by creating a scale on our x and y axes. We're going to be going up by 2 as well as going down in the left direction, -2, -4, -6, and -8. Same goes for our y-axis. We have a 2, 4, 6, and 8. Going downwards, -2, -4, -6, and -8. Now that we have placed scales on our x and y axis, we can begin to graph. We have a y-intercept at 0, comma 4. We're going to place that in blue. We have two x-intercepts, one at 2, comma 0, the other at -4, comma 0. We have a hole, which we're going to create in red at 2, comma 2. That is right over here. We can draw our vertical asymptote at x equals -1. We're going to create a dashed line right over here. And we also have a horizontal asymptote at y equals 1. So this will be another dashed line. We also have an additional point at -2, comma -2. And that is right over here. Now, generally, rational functions are curved lines which approach our vertical and horizontal asymptotes. So, starting off from our bottom left corner, we have a line approaching our vertical asymptote, and we're just going to draw an arrow extending from both sides of this line. Now we're going to do the top right corner as well, and we see a third point right over here that is questionable. So this goes back to our x-intercept of 2, comma 0. Now, when we were solving for 2, comma 0, we had set our numerator equal to 0, but this x minus 2 is actually a whole. So this point does not exist. Now let's go back to graphing the second portion of our rational function. We're going to go from our vertical asymptote, connect to the intercept, connect the whole. We're going to approach our horizontal asymptote, draw arrows on both sides, and that's it for the graph of this rational function. So now that's it for this video. We'll see you in the next one.